Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So hydrogen atoms start in the n equal to 1 state or the ground state. Now using equation 27.10 and equation 27.15b, we determine the state to which the atom is excited when it absorbs a photon of energy 12.75 electron volt. Now, using these two equations, we find that delta E is equal to En minus E1, where En is the state, energy of the state to which the atom is excited after absorbing the photon, and E1 is the ground state energy. Now, we know that En is equal to negative 13.6 electron volt over n square, and we have delta E as the kinetic energy of the photon, which is 12.75 electron volt. Now we use this equation, and also E1 is negative 13.6 electron volt. So we use these values and plug them into this equation to find the value of N, or the state to which the atom is excited. So N will then be equal to negative 13.6 electron volt over E1. Okay, let's just write the expression first. E1 plus delta E and a root over of that. And E1 is negative 13.6 electron volt and delta E is 12.75 electron volt. So we solve it for N and we get this value to be 4. So we know that the electron can be excited to as high as the fourth level, or the n equals to 4 orbit. Now starting with the electron in the n equals to 4 orbit, the following transitions are possible. So one is n equal to 4 to n equals to 3, n equals to 4 to n equals to 2, n equals to 4 to n equals to 1. Then we have n equals to 3 to n equals to 2. We can also have n equals to 3 to n equals to 1. And lastly, n equals to 2 to n equals to 1. Now we use equation, let's move it down a little bit. Yeah, perfect. Now we use equation 27.16 to calculate all the possible wavelengths that can be emitted as the electron cascades back to the ground state. Now, according to this equation, you can also use equation 27.9, that is much simpler. So let's just use that. Now, according to this equation, 1 over lambda is equal to R times 1 over the final state, let's call this NF square, minus the initial state, so Ni square, where R is equal to this, and we got this value from example 27.14. Now the calculations are pretty simple, so let's not waste our time doing each of this. So for this case, NF or N final is 3 and initial N is 4. So we use the value we have to find lambda, and we get the value of lambda to be equal to 1875 nanometer. Similarly, for this case, NF is 2 and NI is 4. So we do the same for each of this case, each of these transition case. So we get for this case lambda is 486.2 nanometer. For this case we have lambda equal to 97.23 nanometer. Here we have lambda 656.3 nanometer. Here 102.6 nanometer. And for the last one, we have lambda equals to 121.5 nanometer. So these are the wavelengths of all possible transitions that the electron can have while cascading to the ground state.